I'm Eric, and I'm presenting my final project, PCAP Timeline Visualization. PCAP files are full of data. You can use Wireshark to see flows, but the way it's displayed may or may not be helpful. TCP flow extracts and organizes TCP conversations, but the output is file-based, and there can be a lot of files to go through. My tool tries to display traffic a little differently. It sorts through packets and displays traffic per host and IP address on a timeline. I provided a compressed tarball that has the code and necessary JavaScript libraries. To install, first create the /op/local/pcaptv directory. Then copy the lib directory and all the subdirectories into /op/local/pcaptv. The script also has a few dependencies. It requires dpkt 1.8, CherryPy 3.2.4, and SQL Alchemy 0.9.7 Python modules. It also requires the Simile Timeline widget, which I've included, and TCP Flow 1.4.4. Get TCP Flow 1.4.4 from Digital Corpora and not from GitHub. Now let's run a short example. Displaying the help, we can see that the script has one required argument and a few optional arguments. The required argument is the PCAP file, and the optional arguments include the --db option, which tells the script to create SQLite databases of the data structures used to create the timeline data, a --c option, which tells the script to consolidate TCP connections. By default, the script displays each side of a TCP connection as a separate timeline event. So the --c option tries to decrease the amount of data that is displayed on the timeline. The --s option tells TCP flow tells the script to skip TCP flow generation. The --dns option tells the script to print out to the screen names and IP addresses that is able to extract from the PCAP file. And finally, the --s verbose option tells the script to generate additional information that is mainly used for troubleshooting. So running the script with a short PCAP file that I've generated, we should always run with sudo privileges because of the location that the script saves its output data, which is /op/local/pcaptv. So running the script, we'll see that the script will create a directory in /op/local/pcaptv called work. And within that directory, it's created a directory with the name of the PCAP file with a timestamp appended to it. Pushing into this directory, we see that there are 4 additional directories created. The DB directory, which will contain the SQLite databases if we've told the script to generate them. The flows directory, which contain TCP 1.4.4 output data. The HTML directory, which contains the HTML files needed to display the timeline data. And the JS directory, which contains the JavaScript object notation text files that contain the timeline data. Now, to display the timeline that we've just created, we have to open up a browser and navigate to localhost:8080. And the browser will display a list of MAC addresses that were contained in the PCAP file. Clicking on one, we'll see the IP addresses that are associated with that MAC address. Sometimes there is only one, sometimes none, and sometimes there are more than one. Usually the MAC addresses that have more than one IP address are routers or hubs. Clicking the IP address, we can see the timeline. The timeline is structured with the hour scale at the top, minute scale in the middle, and second scale at the bottom. When we scroll the timeline, it tends to be a little jerky because of the auto sizing effect that the JavaScript does. So for this particular file, we can see that the the traffic that it's displaying. The script will extract UDP data, TCP data, ARP data, and ICMP data. However, all IPv4. And we can see on this timeline a bunch of blue dots and lines, some green arrows, some red dots and lines, and some A's. The A's are ARP packets. Red dots and lines correspond to TCP connections that we haven't detected a fin for. The green arrows correspond to UDP data, and blue dots and lines correspond to TCP connections where we've detected a SYN and a FIN, so they're closed connections. So clicking into one of these TCP connections, it displays a detailed window and displays the TCP flow output data. The TCP flow output data, and if you click on the title, if there's TCP flow output data, it'll display the TCP flow data in a separate or in the browser. So let's go back and run this again with the --C option. And what we see here is that the timeline looks a little different. And we see a new type of timeline event marked by this blue and white striped blue and white striped line. These blue and white striped lines are closed TCP connections in both directions that we were able to consolidate into one timeline event. So this allows us to decrease the amount of data that's displayed on the timeline. So the timeline also allows you to do some rudimentary filtering and some highlighting. For example, we can filter for macromedia and let the timeline redraw, and we see that in the second window everything except traffic from macromedia is filtered out. So we can also highlight some data. Again, letting the timeline redraw. We can see that we were able to highlight the events associated with CNN.com, which I typed into this window. And so that concludes the demo, and I hope you enjoyed it. Thanks.